So here's a really big word, factorial arithmetic, that goes with permutations somehow. Okay? The idea of this is something like, say I had 3 slots, right? Like chairs, maybe. Right? And over here I had some people. I have this guy with his arms straight out, and this guy with his arms up because he's very excited to be seated. And this guy who's sad. Right? If I'm going to put these people into those chairs, right? So take your things over here, put them over there. How is this different than what I've been doing?
It's a number of ways you can arrange things.
Yeah, please note, you don't get to use sad face guy more than once, right? Like once he's seated, you can't use him again in the next seat because there's only one of him. You guys see that? So, how many ways are there for me to fill the first chair?
3 ways.
3 ways, right? How many ways are there for me to fill the second chair?
2.
Only 2. And how many ways are there for me to fill the third chair?
1 way.
Only 1.
And that's why he's sad face guy, because he moves left.
So, how many total ways are there for me to do all of this thing?
3 times 2 times 1, 6.
3 times 2 times 1 gives you a grand total of 6, right? Now this idea happens so much that I want to define this as an idea. You guys notice I had 3, right? And then I multiplied that by 1 less than 3, and then I multiplied that by 1 less than what I multiplied by before, until I got to using up all the things. You guys see that? So I'm going to make a new symbol to mean that idea.
Does that make sense?
Ugh.
Not sad face guy?
Okay, so 3, right?
Yeah.
So when you're reading this, you read this as 3 factorial. And all this is to give you a way to conveniently write down really, really big numbers. You guys want to see an example?
Yeah. Wait, what is the 3 for again?
So notice 3 was where I started this process. Let me give you another example. What does 8 factorial mean? There's 8 people and 8 chairs. So how many options are there for your first chair?
8 times 7 times 6 times 5 times 4 times 3 times 2 times
Oh
1.
gosh, stop it. You got ahead of me counting, right?
Alright, do that again.
Okay, so lots, right? This is a short way for me to write down lots and lots of numbers. Cool? So, one question we can answer with this quickly is this question that would have been really annoying. How many possible shuffles of a deck of 52 cards are there?
A lot.
Almost broke my calculator. 52 factorial.
Yeah, you can see that this would be a really annoying question, right, if I just wrote down all the slots and then started writing. Like, I'd say, okay, well, there's 52 options for the top card, and then there's 51 options for the second from the top card, and then there's 50 options for the, right? Yuck. Major yuck. You're going to do this anyway, right? You're going to write, and then some stuff, and then what happens at the end?
Times 1.
Yeah, there's maybe 2 options for the last card and 1 option for the card on the bottom. You guys see that? Like, once I've got 51 of the cards out, I know what the last card is. There's just the 1 option there. You guys cool with that? Okay, this is really annoying. So instead of not writing that, I'm just going to write 52 factorial. Cool. All right. Ready for the arithmetic part of this? Yeah, what's up, Frank?
Is the exclamation mark like the actual part of the answer?
Yeah, the
actual-
exclamation mark means do this multiply
Okay.
kind of continually by stepping one down until you get to one. So let me give you an actual precise math definition of that thing. Okay, so actual definition. N factorial. Notice that n there has to be a counting number.
What's the non-counting
Pi.
number? What?
Pi is a not counting number, and pi factorial would be really confusing.
Yeah.
The reason for that, right, is that what this thing means is start with n, right, then multiply by n minus 1, then multiply by n minus 2, and kind of keep doing this until you get to 2 and then 1, right? But if you subtract 1 off from pi, right? No, don't do this. Pi factorial, right, would read pi times pi minus 1 times pi minus 2. That's like how big, give or take? Ballpark? 1.14? Okay, so I can do at least one more. Pi minus, oops, not 1. Pi minus what? 3. So that's like 0.14.
So pretty much
do
any
that.
counting number has to be like a whole number? A positive whole number?
Yeah, whole numbers are counting numbers and also 0. We'll get to what 0 factorial means a bit later when we have to. But for right now, I just want to do natural numbers because it makes sense to do this kind of decreasing by 1 process, right?
Okay.
Even with 0, that doesn't make any sense. You guys see that? We'll make a definition for 0 because we'll need it. But for anything that's not whole, at least, this definition won't make sense anytime soon. A long way out for you all. So a ways out for you guys. There's a way to make sense of this. But it's not convenient. Okay? So for you, for everybody else who hasn't seen a lot of math, just this is not going to happen for a long time. There is a way to make sense of it, but it's way, way down the road. So let's not do that today. Cool with that? Check. Everybody good with this part? Okay. Let's answer another question, I think.